Switching over into the user interface for the Palo Alto Next Gen Firewall, you can see that this is a dashboard and it gives you basic information about the firewall, some of the system logs, the data logs, and how we configure the rest of this IPsec is going to be exactly the same on any of the Palo Alto Next Gen firewalls. We'll switch over to the networking tab in the user interface, and we're looking at interface page here, and we're always showing that we have some configuration on this firewall already. We've done the basic networking configuration to allow this to communicate on a basic Ethernet LAN. The first step in creating an IPSec VPN connection is ensuring that you have an IKE crypto profile that's suitable for your use. What we have here displayed is the predefined crypto profiles. There's a default, Suite B, GCM 128, and 256. Now, if none of these match up to what you're looking to do, then there's always the capability of doing an add and creating your own crypto profile. So you get the selection of different groups for Diffie-Hellman, different authentication schemes, and different encryption schemes, as well as your lifetime for the keys. Again, these must be symmetrical between the two locations. For our use case, we've decided to use AES 128 CBC, SHA-1, and Group 2 with 8 hours of lifetime, so the default is fine for what we're utilizing here. The next step in the process is to create an IKE gateway. If we come under the networking tab at the top and IKE gateways here, we can see that there are no predefined IKE gateways. These are very specific. So we click down here at the bottom to add. From this point, we can give it a name for this IKE gateway, and let's just call it IKE 1. And the version of IKE that we're dealing with, this is IKE v1 only, IKE v2, or preferred IKE v2. If in this case, if we selected IKE v2 preferred, then it would try IKE v2 first and then switch back to IKE v1. We're going to stick with IKE v1. The interface we're dealing with here is our untrust interface, which happens to be Ethernet 1.1. And the local IP address, if we do a pull down, you'll notice the IP address that's assigned to that interface. In cases where it's DHCP assigned, that may show up as none. That's not a problem. It's just this works out better when there is an IP address onto it. The peer IP address, this is the remote end of the connection of this IKE connection. So it's the peer IP address that's facing this side of the connection. In our case, it's 10.0.0.29. The authentication we're using, this is our pre-shared key or password, and we pick Palo Alto. And again, we have to confirm that, Palo Alto. And for identification purposes, we're going to use IP addresses. That comes up in the request and in the initiation. And we're going to put the local in here, which happens to be 10.0.2.198. And the remote, the peer connection, which is 10.0.0.29. In the advanced operations here, this is where we need to select in and pick the exchange mode that we're dealing with. Auto is fine. You have main or aggressive. In the IKE crypto profile, we're going to select the profile that we're using. In our case, default was the one that worked best for us. And then we have a dead peer detection here. This is the interval of 5 and a retry of 5. Usually works out pretty well. If you're dealing with NAT transversal, here's where you select NAT transversal. And passive mode is that it only is going to respond to requests for the tunnel connection, not initiate the tunnel connection. The next step that we need to accomplish is the security zone. This is the third step in the process. You'll notice that we already have 2 zones already created here. These were created previously in our initial configuration of the firewall. To get to this, we go to the networking tab and then under zones. Since we want to create a third zone so that the IPsec tunnel termination terminates in a separate zone and that allowing policy to be zone driven for this, we can come down to the bottom and do an add. At this point, we can put in that it is a a zone name. IPSec is a good zone name. And then we have to pick a type. And this type is a layer 3 policy. And do IPSec. Now that's created. In order for a Palo Alto Next Generation Firewall data plane interface to respond to something like ping or to be a management interface, we have to create a management profile. We do this by going under the network and then interface management. There are no predefined, again, for this, but we can create doing an add and give it a name. In our case, we'll just call it ping and select the network service of ping. This allows that the Palo Alto firewall on this interface will respond to a ping when it receives it for itself. The fifth step in the process is create a tunnel interface. In this case, we go into the network tab under interfaces and then select the sub-tab of tunnel. With this, we can do an add, and we're just going to, it is a tunnel, and we give it a number, something we haven't utilized before, in this case, tunnel 1. We can put a network profile onto this, a netflow profile, but mainly we're going to be configuring the same things that we configure on any interface on a Palo Alto firewall. So what virtual router does it define to? And that is default in our case. And then what security zone? And previously we created that IPSec security zone. The next step is to go to IPv4. In this case, this is where we're going to add that tunnel interface. In our case, we're going to be 10.10.10.2/30. And under the advanced section here, we set the management profile that we just created. So we can, down here, we can find ping that we had just created. And for the MTU for an IPsec tunnel, we recommend 1427 for the MTU size. Clicking OK creates that new tunnel interface. The next step in the process, step number 6, is to create a usable IPsec crypto profile. So this is similar to the crypto profile. Come under the networking tab and come down to the network profiles for IPsec crypto. And if you notice in here, we have 3 predefined already: default, suite B 128, suite B 256. If you needed to create a special one for whatever your environment is, you can come down here and do an add, and it will come up and allow you to create a profile that it will match whatever criteria you need. In our case, what we've been able to use, or what we're planning on using, is AES 128, SHA-1, and Group 1. So the default matches up to what we can utilize here. So we're going to use the default. The last major step in the process is step number 7, is creating an IPsec tunnel. So again, under the networking tab, IPsec tunnels, there are none created. We come down here to the bottom and do an add. We give it a name. We can call this IPsec number 1. The tunnel interface that we created a few minutes ago, which was tunnel 1. The type with auto key, so this is auto keying, rekeying. And address type IPv4. The IKE gateway that we created in the beginning, so this is IKE 1. And the IPsec crypto profile that we created in step number 7, and we're going to use default. Down here we can click on advanced options. So if you wanted to do enable replay protection or copy toss headers or any of those type of things, that's where it's found under the advanced section. If we click OK, we don't have to worry about proxy IDs. This is a route-based tunnel. If you wanted to do a proxy-based or a policy-based tunnel, then you could have to put in the policy-based or proxy IDs in here. We're all configured. Everything is completed. At this point, we can come up here and do a commit for the firewall. And this should commit all of those things that we've set aside here. And as soon as the commit has finished, we should see a successful tunnel creation. You'll notice the red indicator on that this is indicating the tunnel is down. It's IKE is down, so we haven't finished phase 1 of the negotiation. You'll need IKE to be green before phase 2 or the IPSec to be green. And you'll notice now that the IKE tunnel has come up successfully. We are successfully connected. You can see that what we've used, it's aggressive mode, the role is responder, so it didn't initiate it, and here's the algorithm that we've put into it for encryption, when it was created and when it expires. And the same thing for the tunnel information. So what the name of it is, the local and remote peer addresses, all of the information, what were bytes encapsulated